So this is the third video. We're going to be going to cover roughing. What we've looked at now is we've looked at part setup for lathe, we've looked at the stock creation, and we've looked at facing. So at this point we are ready to rough the part out. We're going to use the command roughing, which is under the turning tab. It's the very first toolpath inside the general drop down expanded gallery box here. So we're going to click on rough. Now this is where we get to talk about some chaining methods. So again, you have C-plane or wireframe, and then you have 3D. Now in this case the 3D should work out well for us. In some cases you're going to want to generate a wireframe, which we will probably talk about later on in a different video. In this case here, I'm going to change my wireframe chaining to solids. What I want to do is I want to select the start of my chain near to the start point in the chamfer, because we understand we already have the facing done, so this is where we're going to start our roughing. I'm going to click on that, and now we're going to click on the end of the chain. So in this case, the end of our chain is going to be the last line segment here on the part. We click on that, the red arrow moves, and everything in the middle of that has been selected. So this is the chain we want to machine. We're going to click OK. And now we've entered into the lathe roughing parameters dialog box. We're going to use that same roughing tool that we talked about in facing. We're going to force the tool change so that it comes from the clearance position or the home position. And in this case, we're going to write in the comments rough machine the part. We're going to leave 10 thousandths in the Z, so let's do Z 0.010. That's how I want to do this. We're going to do ZSFF, I believe. Let's just do Z minus 0.010, and we're going to do D 20 thousandths. We're going to leave 20 thousandths for machining in the D. After that, I think we're all set. I'm going to go to rough parameters, and we will discuss what's going on in this area here. So we'll start from the top again and work our way down. We have a depth cuts of auto, equal, or incremental. Normally equal steps is used, and then we can specify a depth of cut. So in this case, it's saying that our maximum is going to be 100 thousandths, and it's going to divide it into equal steps, depending on what the total amount of material or dev moves that it has to make. This is usually what I'm going to leave. We're not going to mess with this too much. There's also a minimum depth of cut, so if you don't want to go less than a certain amount, you can also specify that. We have an entry amount, which is basically your lead in of 100 thousandths, and we have an exit amount of 0. So we'll be discussing that, a change to that in the near future here after we discuss this for a few minutes. So below the depth cut value, we have a stock to leave in the X and the Z. So in this case, this is one of those confusing things. X is D plus when we're looking at this. So, and this is also on the side. It's not on diameter. You see how it's actually specifying it's on the side. On the side means it's a radius. So if we have 0.01 here on the X, if you're actually going to measure it with a mic, it'd be doubled, so it'd be 0.020. So that's actually exactly what we want. And then stock to leave in the Z, it's a linear move, so that does not get doubled. There is no radius there, and that is also correct, 0.01. So this is 20 thou, this is 10. And that's what we specified we were going to do here in the notes. Cutting method, one way is how we're going to usually leave it. And then I do want to point out the rough direction. So we're doing OD turning, so this is the correct turning, what do you want to call it, strategy. There you go. If we open this up, we'll actually see that we have some face roughing, we have ID boring, and then we have some back facing. So if we were doing a different type of roughing, we could change that strategy here. In this case, we are doing OD roughing, so we're going to leave that alone. Good. So this is basically it. We don't need to change much here. I'm happy with this. Again, with this depth of cut. Depending on material and how much you're removing, you may have to adjust this accordingly. Depending on how much chip removal you can take with the insert you're using and how fast we're turning the part. I do want to talk about plunge parameters first, so let's go into plunge parameters and kind of look at this. So what plunge parameters does is it allows you to either machine undercuts or ignore undercuts. Okay, in this case we want to ignore this groove here because the tool that we're using for roughing cannot create this geometry. If you remember looking at the tool nose, it looks similar to this. So as the tool comes through here, it would have to come down here at a 45-degree angle, and there's no way for you to machine this back area. So we want to skip the whole thing entirely and do a separate tool path later. If we did want it to plunge into the features, you could go ahead and change these selections based on what you want to do. So this is everything. You can see that on the floors and also on the walls. This is just on floors only and not on walls, and then this is the walls only and on floors. So those are the four options that we have. Again, in this case we want to select this. If you ever see your tool plunging into a groove that you do not want it to go into with this particular path, this is where you need to go to fix that, so please keep this in mind. The next area we want to look at here with this is the lead in and lead out. So luckily, compared to milling, this is a lot easier. So we have two tabs, lead in and lead out. We have a compass on the right hand side denoting the angle of approach for your lead in and out. For your lead in only, I'm sorry, on this particular tab. So what this compass is telling us is it's going to go 100 thousandths and it's going to come in straight at 180 degrees. If you wanted to change that, you could either type in a different angle or you can actually click the compass and move it depending on what you want. In this case, this is good. I also want to check in my lead out. You see that the normal lead out is also defaulted to 100 thousandths. But this time it's actually at a -45 or a 45-degree angle, I mean, and it's actually pulling away from the part this way or away from the chuck before it rapids. You always want to pull away. You never want to go towards the chuck. You want to go away from the chuck. One thing we're going to adjust on our roughing passes and on our finish passes is I'm generally going to want to extend the contour by a certain amount depending on what cutoff tool we're using. So if we end up manufacturing this part and the tool stops here and goes off, what happens is we're going to have a lip here, right? Your stock size is going to be up here, and depending on how much you've taken off, it's going to have a jagged edge or it's going to have a weird geometry to it. When you come to part this tool off, what we'll normally use is a 1/4 inch or an 1/8 inch to a 1/4 inch thick carbide cutoff bit, which is going to be brittle because it sticks out of the tool holder a certain amount so that it can actually get in here to cut this off. So with that thing sticking out cantilevered like the way it is, you have a good chance of breaking that bit, all right, or shearing it, or just causing vibrations that you don't want while you're trying to part the tool off. So what I generally like to do is I like to go a little bit farther so that we clear this area out and we have a nice flat surface for that cutoff tool to come in and actually perform the cut with. So what we're going to do in the lead in and lead out, again, I'm going to go to lead out, I'm going to extend the contour, and I'm just going to extend it by 200 thousandths roughly. Now you have to make sure that you have enough material in the back for clearance, right? So if you didn't have 200 thousandths back here, you couldn't add that amount. But here there's no conflicts at all. It's not going to be an issue. So after that, I am going to turn on stock recognition here. We haven't really done much, but you'll want to get in the habit of looking at this, because a lot of the times we're going to use the remaining stock to help generate the toolpath that we want. So we'll turn on remaining stock. Everything else here looks pretty good. I'm going to click OK, and we've generated the toolpath. So you can see our extension here. Here's our lead out move, and then the same deal. Here's the straight in path leading in to the part. Now you're going to see some weird geometry or lines generated when you're doing this, but when you watch the back plot, you're going to see that the tool nose is actually on the part where it's supposed to be. So we're going to go ahead and back plot that, and we'll just watch the tool move, go through the motions. So again, this is 100 thousandths per cut, so you can see these are 100 thousandths increments. And then when it gets to the end here, we get down to the very bottom, we'll see how the tool nose meets up with the part. And you'll also notice again that we're skipping the undercut, right, because of that setting. So the tool's not going to be allowed to go in. Now there should be one more pass. Oh no, I'm sorry, because this is 10 thousandths larger, so that's the actual finished pass that we have there. Okay. And if you want to, you can also go into the verify and watch the solid preview. The same kind of thing with the milling. You want to go over and turn your color loop on, and then you can just press play and run. But again, backplot is the one you want to watch. You'll get more information out of that than you will anything else. So that's the roughing command. The next one we're going to look at is finishing. It's fairly simple, but again, I'm going to put that in a separate video just so they're all kind of chunked out so you guys can watch them individually without having to watch a hour and a half long video. Okay, so I will see you in the next one.